look up at the night sky on a clear evening, and you might feel like you're looking at the universe exactly as it is.
Right, like you're seeing it right now.
Exactly. But you aren't. You're actually looking at, well, a museum of ghosts.
Yeah, that's a good way to put it.
Because, light takes time to travel. Every star you see is just an image from the past.
Some of them could have burned out a million years ago.
Right. But their light is, like, only just now reaching your eye. We live in a reality that is fundamentally defined by delay.
We really do.
So, welcome to the Deep Dive. Today, our mission for you, the listener, is to take that mind-bending concept and use it to completely break down how you, and frankly, how classical physicists picture the mechanics of the universe.
Yeah, it's a massive undertaking. And to do it, we're analyzing this highly complex translated Japanese blog post.
Oh, this post is wild. What's the title again?
It's called Draft. Mr. Einstein slacking 146 before mathematics. The world begins with surveying.
Quite a mouthful.
It is, and it's by an author known as Zionad 2023. And this text, it forces us to challenge the invisible assumptions of observation.
It really strips away the comfort of abstract math, right?
Exactly. It makes us confront the gritty, physical reality of the speed of light.
Okay, let's unpack this. The core argument here is that physics basically went off the rails early on by relying entirely on geometry.
Yeah, geometry and abstract math.
Right. They argue that classical physicists started treating the universe with this, like God's eye view, instead of focusing on what they call surveying.
And surveying, in this context, means the actual physical reality of how a particle of light travels across space and eventually hits a retina or a camera lens.
So, to really grasp this critique, the author asks us to visualize this very specific, almost architectural thought experiment.
Right, I want you to imagine a massive empty room. Let's say it's a cube, 20 units by 20 units by 20 units.
Okay, giant room. Got it.
Now, right in the dead center of that massive room, imagine a much smaller 2 by 2 by 2 space. And inside that smaller space, perfectly suspended in the middle, is a crystal ball with a radius of exactly 1.
I'm picturing it. A giant room, a smaller box in the center, and a crystal ball hovering inside that box.
Perfect. So according to the author, classical mechanics, like the physics pioneered by Isaac Newton, treats the entire universe like this room.
The author calls it a miniature garden.
Right.
Or like a sandbox.
Exactly. Newton basically imagined a hypothetical observer standing somewhere outside that crystal ball.
Like out in a larger 20 by 20 room.
Yes, just looking down at it. And from this external detached position, Newton could theoretically track an object inside the ball.
Like the moon orbiting the Earth, for example.
Right. And he could instantly assign it a velocity of 0 just by moving his head or his eyes to keep the moon perfectly centered in his vision.
It sounds exactly like playing a video game in God mode.
God mode, yeah, that's a perfect analogy.
Like if you're playing a real-time strategy game, you can pan your camera across the entire digital map instantaneously.
Right, there's no travel time for your vision.
Yeah, you look at your home base, and then a fraction of a second later, you just click and look at the enemy base 1,000 miles away.
The camera isn't bound by the physics of the game world.
Exactly. But I have to push back a little here. Isn't this abstract mathematical grid, this Cartesian coordinate system, incredibly useful?
Well, yeah, absolutely.
I mean, why is the author so intensely against this grid if it's the exact same math that helps us calculate planetary orbits? Or figure out how to launch a satellite? It obviously works on some level.
What's fascinating here is that the author doesn't dismiss math as useless. Math is arguably our most powerful descriptive tool.
Right.
The danger arises when we start to confuse the mathematical map with the physical territory.
The map is not the territory.
Exactly.
Yeah.
Newton's classical mechanics rely heavily on this concept of action at a distance. It builds a framework that assumes gravity, and the visual information about where an object is travel instantaneously.
Like the video game camera panning across the map instantly.
Yeah, and that instant assumption is the trap. When you try to map multiple massive moving objects, let's say the Earth, Jupiter, and the Sun, from this God mode viewpoint, things get messy.
Because you're assuming you see them all exactly where they are right this second.
Right. And you end up creating what the author calls apparent directions of gravity. You're drawing straight lines of gravitational pull based on where you mathematically calculate those planets are right now.
But by doing that, you're entirely ignoring the fundamental physical limits of the universe.
Yes, namely that nothing, not even gravity or light, travels instantly.
I I see. Because the God mode camera doesn't actually exist in the physical universe, the math starts to describe a reality that isn't physically happening.
Exactly. We're drawing an elegant, flawless map that completely ignores the ultimate speed limit of reality.
And you are forced to wait for that light. You cannot observe anything the moment it happens.
You have to wait for the electromagnetic waves from that object to physically cross the vacuum of space and hit your instrument.
Which brings us to the historical mistakes made by some of the greatest minds in astronomy.
Yeah, the author specifically calls out two heavyweights who tried to measure this delay, Ole Römer and James Bradley.
Let's get into them. Römer and Bradley were pioneers.
I absolutely were pioneers.
They were the ones actually out there trying to measure the physical delay instead of just relying on the math.
Right, so back in the 17th century, Römer was the first person to definitively prove that light had a finite speed.
Wow, 17th century. How did he do that?
He accomplished this by observing the eclipses of Jupiter's moon, Io. He realized that the timing of Io's eclipses appeared to change depending on how close the Earth was to Jupiter in its own orbit.
Oh, because the light had to travel further when Earth was further away.
Exactly. And later in the 18th century, James Bradley calculated the Earth's orbital speed. He clocked it at about 30 kilometers per second.
30 kilometers a second. That's incredibly fast.
It is. And he figured this out using a slanted telescope mounted securely inside a building. He measured the slight angle at which starlight entered the telescope as the Earth moved through space.
And this phenomenon is known as stellar aberration, right?
Yes, stellar aberration.
Okay, so they were actually doing the physical surveying the author advocates for. They weren't using God mode. But Zionad 2023 argues they still critically messed up their observations.
Yeah, they messed up because they baked massive invisible assumptions into their calculations.
What kind of assumptions?
Well, Römer assumed that the sun was completely, perfectly stationary within the universe's electromagnetic field.
Which we know isn't true.
Right. And he didn't do this out of ignorance. He just lacked the technological tools to measure the sun's own movement through the galaxy.
So he calculated the speed of light, assuming the center of his solar system was dead still.
Exactly. And Bradley made a similar conceptual error. He assumed that the Earth's 30 kilometers per second orbital speed was its true absolute speed through the universe.
Wait, hold on. If Bradley is measuring the speed of light coming through a telescope bolted to a building on Earth,
Yeah.
but the entire solar system, like the Earth, the sun, the building, everything, is actively moving through the universe's electromagnetic field, then his calculation is fundamentally incomplete.
Yes, it's missing a massive variable.
He's capturing the apparent angle of the light, not the true source. It's like holding an umbrella while running in a rainstorm.
Ooh, elaborate on that umbrella idea. I like that.
Okay, so if you're standing completely still in the rain, and the rain is falling straight down, you hold the umbrella straight up.
Makes sense.
But if you start sprinting forward, you have to tilt the umbrella in front of you so the rain doesn't hit your legs. The rain is still falling straight down, but from your moving perspective, it appears to be coming at you from an angle.
Right, because you're running into it.
Exactly.
Yeah.
Bradley tilted his telescope like an umbrella to catch the starlight, but he assumed his running speed was the only movement happening.
That captures the mechanics of stellar aberration perfectly. Bradley measured the angle of the rain, so to speak, but didn't account for the entire storm system moving.
Here's where it gets really interesting. Let's use another analogy.
Go for it.
Imagine you are on a high-speed passenger train, and you decide to measure how fast you can sprint down the center aisle.
Okay, I'm with you.
You clock your sprint at 15 miles an hour. But if you write down in your notebook that your absolute speed through the world is 15 miles an hour, while completely ignoring that the train you are running on is hurtling down the tracks at 100 miles an hour.
Then your calculation is practically useless to someone outside.
Exactly. To an observer standing outside in a field watching the train go by, you're moving at 115 miles an hour. Bradley was meticulously measuring his sprint down the aisle, but he ignored the speed of the solar system's train.
By assuming the sun was a stationary starting line, or that Earth's orbital speed was absolute, physics spent over a century working with a warped perspective of observation.
It's wild to think about.
The data they collected was real, but the framework they placed it in was flawed by their own unrecognized motion.
Okay, so if the classical methods of observation are fatally flawed because our planet and our solar system are moving targets,
Right.
how on earth do we correctly measure our reality?
It's a tough problem.
Like, if we can't trust the telescope in the building because the building is riding on a moving train, what is the alternative?
Well, this is where the author introduces a brilliant modern thought experiment to solve the problem of the moving observer.
Okay, let's hear it.
Let's upgrade from the 18th century telescope in a building to a futuristic tank.
A tank, I love it.
Imagine a sophisticated camera acting as our eye, sitting inside a moving tank. And let's say this tank is moving incredibly fast, like 60% the speed of light.
Wow, 60% the speed of light. That is a very fast tank.
Very fast. Let's say it's moving at 0.6 c, straight along a y-axis through the universe's electromagnetic field.
Okay, got the picture.
Now imagine an enemy tank is sitting exactly 100 units away on the battlefield.
Right.
The light bouncing off that enemy tank has to travel across the space between you, enter the tiny front peephole of our moving tank, and finally hit our camera eye inside.
Okay, so it has to cross the gap and get through the slit.
Exactly. The author points out that because our tank is moving forward at 60% the speed of light, the light won't appear to travel in a straight line once it enters that peephole.
Oh, because the physical frame of reference of the peephole itself is moving forward while the light is trying to cross through it.
Yes, meaning the light takes what we call an apparent trajectory.
Because by the time the particle of light enters the front glass of the peephole and reaches the back of the peephole, the tank, and the peephole with it, has moved forward in space.
You've got it perfectly.
So the light doesn't bend, but because the aperture moved around it, the light hits the camera on a slant.
Exactly. So a single camera, a single point of observation inside that tank, can never deduce its true speed and direction.
Because it's essentially looking through a slanted, bent straw.
Yes. To solve this illusion, the author designs a multi-camera setup inside a conceptual slanted telescope within the tank.
Okay, multi-camera.
And they brilliantly name these 3 cameras after ancient Chinese historical figures. It kind of turns a dry physics equation into a tactical battlefield scenario.
I love the flavor of this. Who are our 3 generals and where are they sitting?
First, we have Han Xin. He represents the field camera, sitting exactly at the origin point of our internal grid, coordinates 0, 0, 0.
So he's the eye right on the ground at the entrance.
Right. Second is Xiao He, the strategist camera. He's positioned a bit further back and off to the side at coordinates 0, -10, 1.
Yeah, off to the side.
Finally, we have Lu Bang, the king camera. He sits deep in the back, high above the others at coordinates 0, 0, 20.
Wait, why those specific numbers? Why is Lu Bang way up at 20 on the z-axis, and why is Xiao He offset to -10 on the y-axis? Why not just put them all in a straight row?
Well, if we connect this to the bigger picture, you have to think about the 3D geometry of capturing a moving light wave.
Right, the universe is 3D.
Exactly. To mathematically reverse engineer the warp we just talked about, you need data points spread across all 3 spatial dimensions. Hanjin at 0, 0, 0 captures the exact moment the light wave enters the frame.
Got it.
Xiao He, sitting laterally and slightly deep, captures the lateral drift, how much the light appears to slide sideways as the tank moves forward.
Okay, that makes sense.
And Lu Bang, sitting deep in the back at 20, acts as the ultimate timestamp for how long the light took to cross the entire chamber.
Oh, wow. It's like a conceptual GPS system.
Yeah, that's a great comparison.
Like the GPS in your phone doesn't just ask one satellite where you are. It asks 3 or 4 satellites for a timestamp.
Right.
And by comparing the tiny differences in how long the signal took to reach your phone from each different satellite, it triangulates your exact position on the Earth.
The mechanics are remarkably similar. Because the light from the outside world is coming in on that warped apparent trajectory, it will hit Hanxin, Xiaohe, and Lu Bang at slightly different times.
And the wave will intersect their coordinates at slightly different angles, right?
Exactly. By capturing the same light wave at different depths and offsets, the time differences and apparent light trajectories across multiple fixed points can be measured.
So only through this physical triangulation can we mathematically reverse engineer the slant.
Yes. That is how the tank deduces its true speed and its true direction through the absolute electromagnetic field.
Wow.
One camera is a victim of optical illusion. 3 staggered cameras create a physical triangulation of reality.
That is incredibly elegant. The geometry of it makes perfect sense. But it also raises a massive glaring question for me.
What's that?
If the solution is just triangulating delayed light across 3 spatial points, Why did it take physics 100 years to realize they were confusing abstract mathematical orbits with true electromagnetic velocity?
It's a valid question.
I mean, why were the smartest people on Earth stuck in God mode, drawing straight lines on Cartesian grids for a century?
It raises a very important question, and Zionad 2023's answer is deeply surprising.
I'm ready for it.
To understand why physics got stuck in that rut, the author tells us we actually have to look away from mathematics entirely
Okay.
and look toward linguistics. Specifically, the field of structural linguistics developed by the Swiss linguist Ferdinand de Saussure.
Wait, hold on. Ferdinand de who?
So sure.
We were just talking about futuristic tanks moving at 60% the speed of light and triangulating light waves. Now we're talking about 19th century linguistics.
Yeah.
How does human grammar break a telescope?
I know it sounds like a massive leap, but it is actually the master key to the whole essay.
Right, explain it to me.
Saussure introduced a fundamental concept about how human beings process reality through language. He realized that we often confuse the labels we use for things with the things themselves.
Like mistaking the menu for the meal.
Exactly like that. He divided signs, like written or spoken words, into two distinct parts: the signifier and the signified.
Okay, I'm strapping in. Break down the signifier and the signified.
The signifier is simply the physical form of the sign. It is the literal letters printed on a page, or the acoustic sound of a word vibrating in the air when spoken.
So the word itself.
Right. The signified, on the other hand, is the mental concept. It's the actual meaning or the physical object out in the real world that the sign refers to.
Okay, I follow.
To explain how this relates to our physics problem, the blog post uses a very vivid visual analogy.
Wait on me.
Imagine you have two perfectly transparent sheets of plastic, like old overhead projector slides.
Oh man, taking me back to middle school.
Right. On the top transparent sheet, someone has written the word doji in big, thick black marker.
D-O-G, okay.
That pop sheet, the written word, is the signifier. Now, on the bottom sheet, there are three distinct specific meanings written down, the signifieds.
What are they?
Meaning A is a champion show dog, meaning B is a dog sleeping with a cat, and meaning C is your partner's dog.
Okay, I'm picturing the two transparent sheets.
Now hold those two sheets up to the light, placing the top sheet over the bottom sheet. When you look through the top sheet, when you look through the big black letters of the word doje, your eye pierces right through the signifier and lands on a specific signified on the bottom sheet.
Right.
You read doje, and your brain instantly, without any hesitation, pulls up the image of your partner's dog. The word itself and the specific physical reality collapse into one instantaneous experience in your mind.
It's automatic. You don't even think about it.
Exactly. And the author argues that human beings have a terrible, almost inescapable habit of assuming that the top sheet maps perfectly, one-to-one, with the bottom sheet. We natively assume the label is the reality.
So what does this all mean for physics and the speed of light?
Think about it.
Wait, I think I see it. If we map Saussure's linguistics onto classical physics, the abstract 3D Cartesian coordinate grid Newton's God mode sandbox where everything happens instantly, that grid is the signifier.
Yes.
It's a top transparent sheet. It is just the word .og. It is a human-made label, a conceptual mathematical map that we lay over the universe to try and make sense of it.
You've hit the nail on the head. And what is the bottom sheet?
The bottom sheet, the signified, is the actual messy physical territory of the universe.
Right.
It's the reality where electromagnetic waves crawl through the vacuum of space at a finite speed, carrying delayed information that takes years to reach us.
Exactly. So when a classical physicist looks at their mathematical grid, they say, the Earth is at coordinate X and Jupiter is at coordinate Y right now.
Ah, and their consciousness pierces through the abstract concept, the math grid, and they assume it perfectly reflects the physical territory instantly.
They treat the mathematical label as the physical reality, completely ignoring the delay.
Wow.
By using the coordinate grid as a flawless baseline, physicists accidentally slipped into the linguistic trap of thinking they were standing outside the crystal ball, viewing the universe instantly.
The math grid created an illusion of a universal now that doesn't actually exist.
They forgot that they are physically trapped inside the crystal ball, relying on light that takes minutes or years or millions of years to reach their retinas.
Right, the math isn't the reality.
It's just the language we use to try and describe a reality that is always operating on a delay.
That is just It really shifts the ground beneath your feet.
It definitely changes your perspective.
We've gone on quite the journey today to break down this illusion. We started with Newton's God mode crystal ball, where everything was instant and external.
Yep.
Then we moved through the telescopic mistakes of Romer and Bradley, who, measured their sprint down the aisle but forgot they were running on a moving train.
Right?
And then we looked through the warped, slanted people of a tank moving at 60% the speed of light.
And I realized we needed the 3D geometry of 3 ancient Chinese generals to mathematically reverse engineer our reality.
All to finally realize that the beautiful abstract math we use to describe space is just a linguistic signifier. It's just a word written on a transparent sheet, not the delayed physical reality we actually inhabit.
Understanding this distinction between the map and the territory is crucial.
It really is.
It prevents us from playing God with our scientific observations. We are not external observers standing outside the universe looking in. We are deeply, unavoidably embedded within it.
We're trapped inside the tank.
Exactly. Our entire perception of reality, every piece of data we will ever collect, is entirely dependent on the slow, physical crawl of light through the electromagnetic field. Once you accept that you are bound by that physical limitation, your mathematical frameworks have to change to reflect it.
It's a remarkably humbling thought.
Mm.
And it leaves us with something pretty profound to think about as we wrap up.
Yeah.
If every single thing you observe is a delayed image brought to you by the physical speed of light, then the speed of light isn't just a math variable.
Right.
It is an impenetrable shield of time. Think about the search for extraterrestrial life, like SETI.
Oh, that's a fascinating point.
We point our telescopes at exoplanets millions of light years away, hoping to see signs of advanced alien civilizations. But because of this physical delay, if an incredibly advanced alien civilization 65 million light years away is looking at Earth right now through a super telescope, they aren't seeing our cities or our satellites.
No, they're seeing dinosaurs.
Exactly. They're seeing dinosaurs. We might be entirely surrounded by other civilizations in the universe, but because we are all trapped looking through the delayed peepholes of our own moving tanks, we are walled off from each other in time.
We can never experience the true now together.
We might be completely alone in the present, surrounded only by the echoes of the past, something to mull over the next time you look up at the stars.